So the last unit of the year has nothing, not a little bit, it has nothing to do with anything we've done so far. It is a completely different branch of mathematics. This is an algebra course. What we're about to learn is statistics. And over the years, as curriculum has changed over the past decade, I think that, because overall, who knows? I don't know what the impetus of it is. Maybe it's because colleges and universities want more kids studying this. But statistics has kind of crept its way into algebra. It's not just this school. It's not just this district. It's across the nation now. First, it made its way back into Algebra 2, and then now it's even back into Algebra 1. Okay? You may have even seen some of this in middle school. I've never taught in middle school, but I'm sure, when I show you the first thing, hey, what's the mean? If I have a group of numbers, what's the mean? What's another word for mean? Yeah, the average. Has anybody here never heard of mean before? You've never heard of mean? Average? Oh, okay. And when you study mean, what other two, it kind of just like jingles, it like rolls off the tongue. What other two types of measurements do we also usually study together with mean? Median or mode. Mean, median, mode. So we'll go over them. Oh, I guess I have mode a little further down the page, but it's there. It's coming up. So, when you statistics is the math that revolves around measurements that concern data. Data is like information. If you're given information and then you want to be able to interpret that data to try to gain something from it, that's what we do when we deal with statistics. In many cases, it's you try to use statistics to be able to get a small sample, learn something about a small sample, and project that over a larger population. It could be maybe because you want to know who's going to who people are going to be voting for in the next election. It could be used to figure out, what are some trends that are happening in, with student grades and whatnot. But that's what we're going to learn. We're going to learn different measurements. And it seems to be working a lot for somebody who's never heard of. Huh? Yeah, I know, but I could let's just go through it. You just finished saying you've never heard of it before, so. So these are all going to be different measurements that can be taken when you're given a group of numbers, when you're given a set of numbers. So the first one is the mean, okay? Also known as the average. You should be familiar with average. The way you find average is you add up that set of numbers and then you divide by how many numbers there are. Okay, that's also known as the arithmetic mean. The median, okay? Median and mean are very similar because they tend to tell you something about the center of a group of data, like what's in the middle of a group of data. But they're not the same. Without reading, can somebody tell me what median is? What you know from previous knowledge about median? Nobody remembers anything about median? It's the one number that's in the middle. See, mean asks you to add up all the numbers and divide by how many numbers there are, so that kind of tells you. I'm trying to define it without using the words, but that tells you like what the middle should be, I guess. Whereas median tells you where the middle is. Okay, in order to find median, you have to put numbers in numerical order from least to greatest and pick the one in the middle. The problem is, depends on how many numbers there are in a set of data. Because you're only going to have a number in the middle if you have an odd amount of numbers. If you have an odd amount of numbers, there's one in the middle, and then whatever. If you exclude the one in the middle, you have the same amount of numbers on each side. You have the same amount of numbers that are less than as the same amount of numbers that are greater than. But if you have an even amount of numbers, then this median, it almost acts slightly as an average because you would have to add, because now when you have an even amount, like let's say I have 10 numbers. what would be the two numbers in the middle? 10 is an even number. What would be the two numbers in the middle? If I were to have 10 numbers, if I were to write 10 numbers on the board in order, what numbers would be in the middle? The fifth and sixth, sure. I'm supposed to. Do I have to open it or something? Do I keep it or just go ahead and sign the stuff on the inside? We have 7 class periods in a day. What period is in the middle of the day? What period where like when you're sitting in this period, you've already had as many classes as you still have left in the day? 4. Why? Because there's 7 periods. 7 is an odd number. When you have an odd number, you clearly have a number that's in the middle. When you're sitting in 4th period, you've already gone to 3 classes, assuming you got to school on time, and then you still have 3 classes left to go. That's right in the middle of your day. But if we were to move to 8 periods, now there would be 2 classes that would be in the middle. Okay, it would be your 4th period and your 5th period. The one I asked you 10, if it was 10, it'd be 5 and 6. So if you have an even amount of numbers, you're supposed to add the 2 in the middle and then divide by 2. Now, I don't know, but I haven't looked at every single question that's in this packet closely, but just if it ever comes up, the main difference between mean and median, because if you want to try to get a measurement of what's supposed to be in the middle, is that, I mean, I would probably argue that mean is used more often, average is used more often, but they say that median is a better measurement of center because it's less influenced by the extremes. Let me give you a perfect example, right? Let's say I want to figure out which of my classes has which one of my classes is the best. I only have one of these algebra 1s, but let's assume I had 6 algebra 1s, and I want to know which class is performing the best. Okay, and I look at this class average. This semester you guys are actually doing pretty good. It's like somewhere in the 70s, right? But when I see somewhere in the 70s, I'm talking about mean. I'm talking about average. So the problem with that is that doesn't necessarily give me a good indication of how everybody's doing, because without giving names, there are at least 2 of you in here that are doing way better than everybody else. Those would be the extremes. So what happens is, if even on the contrary, if you had a pretty good class, but you just had 1 or 2 knuckleheads that were doing like nothing, and had like these averages of like 0 and 7 or 8, that had like a really low number, that's going to affect the mean of the entire class more than it would the median. When you have numbers way out in the extremes, it affects the mean more than the median. So if you want to have a better idea of what the middle is, they say that the median is usually a better indicator because it's less susceptible to the extremes. It's not going to be affected as much by the extremes. Does that make sense? Like if I were to tell you right now, this class average is 74, does that mean that everybody has a 74 here? No, probably not. Now, a lot of you probably would be around the 74. That doesn't mean a lot of you are a 74. But then the question is, why do we have that 74? Is it because everybody's close to 74? Or are the majority of you maybe in the 60s, but then we have a couple of people that are doing really, really, really well? Or conversely, maybe a lot of you guys are in the 80s, but then you have a couple of people who never show up to class, they do nothing, their class average is like a 4%, and they're bringing the extremes move averages more than they do medians. So I know that should be coming up later, so when it does come up later, now you know. Okay. Another thing you're gonna start when we start looking at spreads, distributions. I'm not a very good artist, but that's okay. When you start looking at yeah, this will be more next week, because next week we start getting more into distribution. You start seeing histograms and different types of charts and stuff. Um, when you start looking for what's in the middle, right, you're gonna start saying, hey, like median, mean, like let's say. These are two different distributions. Sometimes they'll give it to you like this as a line. Sometimes you'll see it as like a bar graph, okay, or whatever. Um, so what'll happen a lot is they'll say, hey, this little line that's drawn. These are two different ones. These have nothing to do with each other. They're two different ones. They'll draw a little line and they'll tell you, hey, that's the median. Okay, today we'll get into a little bit with box and whisker plots. If we don't get to it today, it'll be this week. Where we'll say and they call it Q2. Um, they don't do that on these, but they do that on the box and whisker plot. They'll say that's the median, but then they'll ask you, hey, if the median is where I just drew that green dotted line, if this is the median, where would the mean go? The mean is always going to go on the side of the tail. Think of it like a little rat with a tail. If this were like a rat, like where would the tail be, on the left side or the right side? I know you're stuck with my drawing. I don't have the best drawing, but if I were to, does that look more like the tail is on the left or on the right? Yeah, on the left. I did a little bit better with this one. This one you can tell where's the tail, where's El Rabito on that one. On the right, yeah. So if you were to be asked where would the mean fall, the mean is always going to fall on whatever side the tail's on. Just keep that in mind also. Yeah.
The tail outline.
One doesn't necessarily have anything to do with the other. Okay. Yes, an outlier could fall into a tail, but that doesn't necessarily mean that a measurement that's in a tail would be an outlier. Kind of, it could be. It could be as a histogram. It could be a dot plot. When you start looking at frequency, like how often something is occurring, all right, we're gonna store these measurements are gonna come back. So, let's see if I can. So let's see if we can do some hands-on learning. You guys, or if it was I think it was my other classes that had a better one. Okay. I think I have better examples of this, but here's an example. And it's perfect. It doesn't have any names on it. This is a histogram of for my trailer courses. I gave them a practice test for the midterm. Before they took their midterm, they took. I know you guys took one also. The difference is yours was created by the department, whereas mine I created it myself, right? So if I were to get this histogram, and I know it's rough, I know it's not perfectly smooth, but if I were to kind of trace more or less, if I were to trace, smart. I need to restart. Whatever. I won't be able to draw it, but if you can just kind of trace the tops of where they are, would you say that the tail is more towards the right, towards the higher numbers, or more towards the left of the data? Yeah, it looks closer. I should be able to draw, but I can't draw right now. But if I were able to draw, um, it's that I need to restart my computer. I guess I haven't done it in a while. There's the same thing, right? So if I were to trace like a little line on top, the tail, okay, like the little tail appears to be on this side of it. This is the tail here, right? So what I would assume, if I could look at the data for this, which I actually do have it, I can look at it now. What it looks like is that, remember, the median is going to be wherever the highest frequencies are. So the median probably looks like it's somewhere around here. That has to be. You're not going to be sure by looking at this, but it looks like the median here would be probably somewhere in this like 12 range, somewhere that 13 range. But the mean should fall on the side of the tail. Whatever side the tail is on, where the mean is. All right. The one thing I can be pretty confident about looking at this data, it looks like the mean is going to be greater than the median. Okay. And let me see, because I think I actually do have that data. Let me see. Before it was normalized. Their mean, it's about the same. It was about the same. Wait, yeah, is this the same one? Oh wait, no, wrong one. Should be this one, midterm. I was looking at a different test. Yeah, it's still pretty close. The median here is 9. So I was saying the median should be around 10, but it actually ended up being around 9. This was the median, and the mean was around 9.9, so closer to 10. Well, at least we were right about that. The mean was closer to where the tail is. Does that make more sense now? Don't really need to get into that this week. That's more next week. But I just want you to know on the front end, those are the two main things people talk about when they talk about mean and median. Okay, let's keep on going down the page. Quartiles. This we will get into today. Quartiles, the reason why it's blue, what else do you see that's blue here? The median, right? Quartiles has only to do with median. It's basically the median of the median. If I get a set of data and find the median, I'm cutting it in half. We talked about like, hey, what's the median period of the day for you? 4th, right? Well, now if I have period 1, 2, 3, 4, 5, 6, 7, and I tell, okay, the median is 4. Well, what that's doing now is it's breaking the other periods into 2 teams. You have the periods before and the periods after. What would be the median of the periods before? 2. What would be the median of the periods after? 6. Okay, so what you call 2, you can either call it the lower quartile or you call it quartile 1. Whatever the first median of the median would be called quartile 1. Whatever the second median of the median is, that's quartile 3, or you can call it the upper quartile. One thing you need to be aware of, and we're talking about something here that we're all familiar with, right? Periods of the day. We said how many periods of the day are there? There's 7 periods in a day. Is that an odd number or an even number? An odd. When you have an odd number of elements of data, they call those elements, like each little, like whatever numbers that you have. If you have an odd amount, when you're going to calculate quartiles, you have to take the middle one out. In order for there to be 3 and 3, you have to exclude the one in the middle. if we were to be let's say we were to be in an 8-period day. Okay, that's an even number. In order to figure out the quartiles, we would have to leave everything and nothing would be excluded, and then you would have 4 and 4. How would you then find your quartile 1 and quartile 2? The same way you do with median. How many numbers are on the left side? 4, right? If there was an odd number, cool, let's pick the one in the middle. But since there's an even number, you'd have to average the 2 in the middle. What's the average of 2 and 3? Huh? 2.5. Your quartile 1 would be 2.5. This will make more sense when we start doing examples. What would be quartile 3 here, or the upper quartile? 6.5. If it doesn't make sense, it'll make more sense when we start doing examples. Mode is just the most frequent. This is what I'm going to spend the least amount of time on. We don't really use a lot of mode. Just things to know about mode. If no number appears more than once, there is no mode. That's something where, like, if you don't look it up, you wouldn't know just using logic. If every number appears exactly once, that set of data has no mode. Okay? But if there are 4 different numbers that appear 3 different times and 3 is the most, then you are able to have multiple modes. It is possible that you could have more than one mode. And if you're eating ice cream, then you're eating a la mode. So that's also important. Okay, range. Okay, thing to remember about here. This is color coded for you. 2 types of range. The thing we're doing in common is subtracting. When you calculate range, you're subtracting. When you calculate regular range, it's just the biggest minus the smallest in the entire set. When you're being asked for interquartile range, it's always upper quartile minus lower quartile. This is used to figure out spread, to see, like, you know, how spread out scores are. But this is used to calculate something that Nakai said earlier, which are outliers. Let's say I wanted to look at some grades in a group of people to say, hey, maybe these students were misplaced. Maybe these students should be in a higher level of math or a lower level of math. You know, if I wanted to measure, you know, at the very least, do these 1 or 2 students, however many you're looking at, do they belong with the rest of the group? Or are they considered outliers? An outlier is something that it just does not belong with the rest of a group in data. And the way that you calculate outliers is once you get this interquartile range, you multiply it times 1.5. Feel free to paraphrase if you don't understand the way I wrote this. I don't know why this came out this way. I guess maybe you should put it I think I used to have a plus minus there. There should have been a plus or minus. So you get the upper quartile and you add 1.5 times the interquartile range. You get the lower quartile and you subtract 1.5 minus the interquartile range. If anything falls outside of that, it's considered an outlier. It'll make sense when you see the examples. Yeah, this next one is kind of an example. It's like a graph. Look, this is the main, as far as data displays, ways to display data, this is the focus of this week. We don't get into histograms and other types until next week. Okay, box and whisker plot has everything to do with median. So here, let's say this is a group of data here. It could be whatever. How many points Nakai scored in basketball games this year? Let's call it that. He scored 14 points in his first game, 30 points in the second game, 16 points, then 20 points. Yeah, he had a good season. 18 points, 16, 20, 18, 22, 13. And then in the last game, he was on a minutes restriction because we had already qualified for the playoffs, so he only scored 8 there because he didn't play that much. When you're going to do a box and whisker plot, you need to find your medians and your quartiles. In order to do that, you have to put the numbers in order. How many numbers do I have here? Are there 11? 1, 2, 3, 4, 5. Yep, 11. Good. And then what they've done for you is they put them in order. Is 11 an odd number or an even number? Odd. So that means as far as the median goes, you should have exactly one number in the middle. What is that one number in the middle? Huh? Okay. Where it says Q2, anytime you see Q2, that's the same thing as saying the median. Feel free to write in median. Okay. The maximum is your biggest number. The minimum is the lowest number. Because 11 is an odd number, if you're going to calculate quartiles, I told you would have to take the middle number out. When it's odd, you got to take the middle number out. How many numbers are there left on each side? If I take the middle number out, how many are there on each side? 5. Is 5 an odd number or an even number? Odd. And because that happens to also be odd, there should already be one number in the middle. We don't have to take the average of anything. So the number in the middle on the front end is the 14. That becomes quartile 1, or what we call the lower quartile. And on the high end, it's 20. But before you can do a box and whisker plot, you need to see if any of these numbers are considered outliers. If I'm trying to figure out what type of basketball player Nakai is, I got to figure out, hey, you know, on that high end and the low end, when he scored 30, was that just because maybe he was playing against such a bad team that was just way out of control? Like, I should never really expect him to score 30 again. Or on the low end, you know, maybe he was hurt that day, or maybe, you know, if I want to know, like, try to figure out the likelihood that one of these extremes would happen again, if I want to know how, you know, do they really belong with the rest of them, I would want to calculate to see if they're an outlier. Are they considered to be outliers? Like, very unlikely to happen again. So the way you do that is you would first calculate your interquartile range. How did I tell you to calculate interquartile range? Subtract what? And anytime you see range, you subtract. What do you subtract for interquartile range? The upper and the lower quartile, which is 20 minus 14, where 20 minus 14 is 6. But then you have to get that interquartile range and multiply it by 1.5. What is 1.5 times 6? What is 1.5 times 6? Ready, set, calculate. It is 9. So then what you're supposed to do is get your low quartile. What was my low quartile? 14. And then subtract 9. And then go to the high end, which was 20, and add 9. So what this tells us is that any numbers that are either less than 5 or greater than 29 should be considered outliers. They should really not be considered part of the rest of the bunch, and it is extremely unlikely that it would ever happen again. Can any of these numbers here be considered outliers? No. Are any of these numbers... I can't draw on this thing again. I'm just not drawing anywhere. This one lets me draw, this one doesn't. Now it's gone. Hold on. Let me close this out and open it up again. Martha, it's all your fault. Okay, so let's see if this will work now. What this is telling, remember, the way that I got these 9s are by getting by getting 6 and multiplying it times 1.5. I took it away from the low end, I added it to the high end. Do any of these numbers up here fall outside of that range of outliers? Are any of these numbers either less than 5 or greater than 29?
Yes.
Which ones?
30.
Just 30. So, all of those seem to be in the correct group, but the one that seems kind of out of place is the 30. If indeed these were like Nakai's scoring games this year on the basketball team, it would seem unlikely that he would score 30 again. Okay. Now here comes the box and whisker plot. Now that we have all that information, here's what a box and whisker plot looks like. Okay, you have a number line. The box on the number line, the outline of the box goes from quartile 1 to quartile 2. And then just connect make it look like a rectangle. Okay, this first line here is Q1, this is Q3. The line in the middle is going to be wherever the median was. Where did we say the median was going to be? 18. Okay, this is Q2. Then wherever your lowest and highest point are, as long as they're not considered outliers. What was our highest point that was not considered to be an outlier? No, 30 was the max, but it ended up being an outlier. So what was the next highest one? 22. You see a point there, and then that's the whisker in box and whisker. The box is the rectangle. That little line is like the whisker, like a cat whisker. Meow. What was the minimum? 8. Was 8 considered to be an outlier? No. So that's why you can put a point at 8. But we need to be able to describe the entire data set. Even though Nakai might not be likely to score 30 points again, the fact is that he did score 30 points. So the way you would do that, you just don't connect it with a whisker, but you would still put a point out at 30. Any questions there? Because now the rest of the packet is going to be examples. So let's see how many we can do, and then we'll move on. All right, mean, median, mode. For mean, you do not need to put the numbers in order. You just have to add them. So let's see if I can do this mentally. For this group A is 16, 18, 21, 26, 32, 36, 42, 53. I know some of you guys are ahead of me. Did those add up to 53? They did? Okay. And then divided by how many are there in total? By 9. Okay, so it is possible to get a decimal. It looks like it's going to be a pretty nasty decimal. It's going to be like 5.1. 5.6. 5 and 8, 9. So then what'd you get then? 5 point. And it doesn't tell you what around. So let's just say it's going to be around 5.1. For the median, you would have to put them in order. So let's see, 2, 3, 4, 5, 6, 7, 9, and 11. Always check, because even me, I sometimes mess up and I forget to put some of these in. It looks like I do have 9. Is 9 an odd number or an even number? So because it's an odd, I should have 1 directly in the middle. It's whatever the 5th one is here. The 5th one is 6. That also is my median. Notice how, in this case, the mean and median are pretty much the same. The mode, just for fun, you don't have to have a mode, but does this set have a mode? Remember, mode is the most frequently occurring. Yeah, it is 6. 6 is the only one that appears twice. Let's do the next one. Oh, geez. Let's do this, man. 47, 74, 8101, 120, 147, 180, 214, 234, 255. You're getting 222 for the second one? I got 255. And you want to break the tie? I did it in my head. For B, what do all of those add up to? 256? Martha, I was close to Martha. I win. 52, 256? Yeah. Okay, I'm going to trust you. Don't make me look foolish on video. So 256 divided by how many are there? 1, 2, 3, 4, 10? Are there 10 of them there? Okay, so that's going to be 25, 26. That's the mean there. For median, you got to put them in order. So 19, 20, 21, 21. It's a good idea maybe to scratch these off as you go for median, so that you know you've already used it. 23, 27, 27 again, 31, 33, and 34. When you have an even amount, what do you got to do to find median? What do you have to do to find median when there's an even amount?
The middle.
Get the 2 in the middle, add them, and divide by 2. You're basically taking the average of the middle. So here the 2 in the middle are 23 and 27. So 23 plus 27 divided by 2 is 25. The median here is 25. Does this set have a mode? Yes, it actually has multiple modes. It has more than one mode. What are the modes here? Yeah, 21 and 27. Those are both modes. The only way it wouldn't have a mode is if nothing appears more than once. Look, this last question today I already answered for you. Which center measure is most appropriate and why? I haven't even done the problem, but I already know what the answer is going to be there. Which center measure is usually the most appropriate? Huh? The median. Why the median? It's less susceptible. Unless you can think of a better word, less susceptible. Let's call that right. To extremes. Here's a group of data. See, a person is trying to find. This will be the last one today. New employees to work for his company. She wants to show applicants a statistic about how much they make. Which measure of center would be best to describe the salaries if she knows that 10 of her employees make? Oh, well, okay, well, this is a skewed question because it looks like it's coming from the viewpoint of the person who's doing the interviewing. If you own a company, do you want to make it seem like your company gives out bigger salaries or that you pay less? Yeah. So you probably have to find it first and then see which one ends up being higher, and then that's the one you want to go with. Like typically, like if I'm the one who's being interviewed, I'm gonna want to use median because median, if 9 people make $20,000, but then one person makes $5 million, that mean it's gonna be huge. But in reality, a bunch of people are making peanuts. You understand what I'm saying? So like median would be the better one, to be the more accurate one. But if you're the boss and you're trying to make it seem like you pay more, we gotta see which one will be better. Did anybody add these up already? I did. What'd you get for what did they add up to? I did. You didn't add them up? What, you went like on the calculator on an app does it for you? You can write it down. 21, I think it's 112. How much? 710 and then 000 divided by 10 because there's 10 of them. So that would be 71,000 is the mean. The median, you have to put them in order. I guess they kind of are in order since there's 10 of them. It's these two in the middle. Are those the two in the middle, right?
Yeah.
So, I know that they're not in order, but I'm saying, oh, but the 70. I didn't catch. So it'll be these two are the ones in the middle. I know it's not in the middle, but I'm trying to save time because the bell's about to ring. 81 and 88 are the ones in the middle, you think? Yeah, because this is third, fourth. So this is fifth. Okay, so these two are in the middle. Okay, yeah, all right. And yeah, because then the ones in the 90s are bigger. And then that averages out to 85.5 or 84.5. 84.5. So the median ends up being 84.5. So if I'm the boss and I'm trying to make my business seem better, would you use the median or the mean here? If you're trying to make the, yeah, yeah, it would be the median. But if you're the person being interviewed, well, which one would be more important to you probably? Actually, you know what? Median would still be important because still median is the most accurate one. So median works out well. And which one was the mode? Is there a mode here? 91. Okay, so the 91,000 is the mode. Tomorrow we'll start with the next page. Histograms. These will start getting into today a little bit. So here's just an example of histograms, right? The age at inauguration of U.S. presidents. So here's a table that tells me that when they were inaugurated, there were two different presidents that were between 40 and 44 years old. There were 7 that were between 45 and 49. 13 were between 50 and 54, so on and so forth, right? So that same data can be displayed by using a histogram or what you guys call a bar graph. You might have called that before, because what it does is it measures the frequency as a bar. The higher the bar goes, the more that there are. So this first bar measures from 40 to 44. How high does that bar go? How high does that bar go? 2, yeah. Yeah, it goes 2 units high. The next one is presidents from 45 to 49. How high does that bar go? Yeah, 7, sure. And so on and so forth. The higher it goes, where these heights, the heights of the bars, are supposed to measure the frequency of how many presidents were each in each range of ages. Now, one thing that I do not have I just don't have like a graphic for. I didn't. They're gonna show up. I don't have a graphic for, but it's very similar to histogram. Is a dot plot. Okay, so when you start seeing dot plots are kind of like histograms, but then the only thing is instead of bars, they use dots. So like, how many presidents were between 40 and 44 when they took office? 2. So what they would do is like you wouldn't even need that. You would just put like 2 dots going up. You'll see some of those. How many presidents were between 45 and 49? 7. So you would see, 1, 2, 3, 4, 5, 6, 7 dots going up like that. It's very similar to a histogram. You'll see some of those. Once we start getting into these dot plots or histograms, we can start to study the shape of a distribution. Luckily, I hope that I saved us some time because I started kind of talking to you about this last week. I told you to expect this week, the different shapes of distributions. Okay? If you trace the tops of either the dots or the bars, that's what gives you the shape, right? What characteristic of the shape is probably the most important thing to look at? You remember? The tail, very good. We talked about the tail. So, and a negatively skewed distribution, okay, what appears to be the tail of like the little mouse is on the left. On a positively skewed distribution, the tail is on the right. If there really is no tail, what was called a two-tail, then this would be a symmetric distribution. It would have the same amount of tail on both sides. This is just a very quick way to look at data without having to be too analytical and try to study it. What I tried to teach you last week quickly, because we got into this because we were talking about mean and median. The mean is always going to follow the tail. Whatever side the tail on, if you're comparing mean and median, the mean is always going to be closer to where the tail is. If you have a symmetric distribution, then the mean and median are pretty much the same. It's all approximate. They don't have to be exactly the same, but it's approximate. One other type of distribution that we'll eventually get into is a uniform one. I didn't have a better graphic of it, but if you were to trace a uniform distribution, it's just flat across like that. Don't get uniform symmetric. So like meaning all the bars, if these were all bars would be, at the same height straight across. If every single one of these president things was like, for instance, 3 presidents were this whole, 3 presidents, 3 presidents, 3 presidents, 3 presidents, 3 presidents. How would that look like as a distribution? It would be uniform. The tops of the bars would be the same all the way across. Any questions there? I'm just trying to get through this quick so we can get to the examples. Okay, a line graph. A line graph is somewhat similar to a histogram, where there's 2 axes. Okay, just like a histogram had 2 axes. Look, there's going up was number agreed to be part of a research study and report their scores. A leadership score is based on a player's answers to leadership questions. A score of 1 to 40 is considered a beginning level leadership score, and a score of 41 to 60 is considered middle level, and a score that's greater than 60 is considered advanced. Use the following data to make a dot plot of the female scores, a dot plot of the male scores, and a dot plot for the scores of the combined group of males and females. Okay? So we got to see the frequency. We got to see how many of each. Yes, thank you. How many 10s are there for the females? How many 10s is 1? So I'm going to put 1 dot. How many 20s are there for the females? 3. So I'm going to put 3 dots. How many 30s are there for the females? Also 3. So I'm going to put 3 dots. How many 40s are there for the females? Also 3. So I'm going to put 3 dots. How many 50s are there? There are 2 50s. But now there's also a 55. So in between the 50 and the 60, I'll put a dot. How many 65s are there? 4. So in the middle here, 1, 2, 3, 4. Then 70s, how many 70s? Also 4. 1, 3, 4. There's no 75s, but 76 is pretty close to 75. How many 76s are there? 8 of them? Okay, so 1, 2, 3, 4, 5, 6, 7. Nakai is not here right now, but he was asking about distributions. You never know until you check it for sure. But what type of distribution does this appear to be? Yeah, negative, but it was called skew to left. Skew to the left. The tail seems to be somewhere on the other left. Dan, you follow me or no? Okay, so now let's go to the males. How many 15s? 1. There's no 10, it's 15. How many 20s? 2. How many 25s? 4. So 1, 2, 3, 4. How many 30s? I'm counting 5. Well, you're right, 6. Wait, how many 35s? 5? 1, 2, 3, 5. 3 40s. 1, 2, 3. Definitely, they weren't as high. They're more bunched up. When it's spread. 45s are going to be 3 of them. And then there's 1. This appears to be a more symmetric distribution. Then at the end, the leadership just means add them all up. But since we've already done dots for, we don't have to go back and look at the table. I would just count dots. How many total 10s were there? 10 is 1. Then as far as to the 15s, there'd be 1 there. Then for the 20s, there's 2, 3, 4, 5. Then in the middle, there's 4. 1, 2, 4. For the 30s, it's 9. 35, there's 5 of them. 1, 2, 3, 4, 5, 40. How many 40s are there? 6. Good. 1, 2, 3, 4, 5, 6. 50. There's 3. I'm sorry, I skipped 45. Sorry, I skipped 45. There's 3 45s. There's 3 50s. 1 55. And then the rest is just going to be a copy of the 2. 1, 3, 4 65s, 4 70s, and then how many was it? 8 76s. This distribution seems to be kind of all over the place. Any questions there? Did I skip a page? Oh, no, sorry, yeah, this is the one I'm talking about. All right, so let's go this way. What do you think is a typical score for a female user? What do you think is a typical score for a male user? And explain how you would determine these typical scores. With the word typical, I equate the word typical to median. So if we understand the shapes of distributions, the mean is going to follow the tail more. So for the female one, the mean will probably be somewhere on the left side. Like, what would you estimate would probably be the median? It could be. There was what? There was 30 females. So the median would be the 15th and 16th scores. There's 8 and 8, 16. Yeah, so we have about 65 is a typical score for a female. So female would be 65. For a male, what appears to be, see, the male is more symmetrical, so the mean and median should be more closely bunched together. It appears the typical score is going to be what 30? And then why is it more difficult to report a typical score for the overall group? Because the shape is irregular. It's all over the place. If we trace the tops for the combined, first it goes up, and then it goes down, and then it goes up. whereas the male was more symmetrical, and the female a little bit off, but for the most part, it appears to be more skewed to the left. Tail appears to be. The following histogram represents an age distribution of the population in Kenya. What do you think this graph is telling us about the population in Kenya? Okay. Look at the shape of the graph. Interpret that. And those 17% of people are between 0 and 5 years old. 15% is between 5 and 10. Let me ask you a better question. I know this says Kenya, but I would expect to see this type of shape anywhere you look at it. Because what tends to happen to people as they get older? Yeah, they die. They stop existing. So that's what this is telling me. What do you think this is telling us about the population of Kenya? As people get older, they die. They didn't really ask a specific question. Why might we want to study the data represented by this graph? I don't know, life expectancy maybe? See how old we would. Nakai, what type of skew is this? Yeah, positive. You can say a right skew. Tail appears to be there. The mean, if you were to calculate the mean age, it'd probably be somewhere in this area, whereas the median is going to be somewhere around there. Based on your previous work with histograms, would you describe this histogram as representing a symmetrical or a skewed distribution? Well, we just answered that one. It would be skewed. And in what direction would it be skewed? To the right. Or if you say a positive skew, that's fine. What would be an explanation for that? What do you look at that determines if you're symmetrical or skewed? The tail, yeah. Sketch a histogram that is uniform. Okay. I did this for you on the first page. What does a uniform distribution look like? Yeah, they're all the same heights. The histogram would look like that. Something that's skewed left would be like the little ones would come first, and then it would get bigger. Skewed right would be the opposite. The big ones come first, and you get smaller and smaller. And then symmetrical would be little and then big. And as you're getting the median and the mean are more or less. Kiara Jackson, how dare you? The main objective for today is to get through mean absolute deviation, which I'm confident we will. The main goal for tomorrow is the two-way tables. And then Thursday was supposed to kind of be like a review day, flex day, but now the IT team added more stuff on scatter plots. So I don't know. Friday's looking up in the air. I don't know if we're gonna be able to finish all by Friday, but we'll see. All right. So if 6 girls have pets weighing 0 to 3 pounds, 5 have pets weighing 3 to 6 pounds, and 2 have pets weighing 6 to 9 pounds, draw a histogram representing this data. Okay, so it's a histogram. What's a histogram look like? Yeah, like a bar graph. We need to have 2 axes here. What do you think the horizontal axis should be here? Hmm? Yeah, the horizontal axis. Yep, pounds. Yep, I agree. 0 and 3 and 6 and 9. And then what should the vertical axis be? Number of pets. And 6, 5, 2. So our, let's go up to 6. All right, let's do all of them. 1, 4. All right, so from 0 to 3 is have all 6. We go up to the top. From 3 to 6 pounds is gonna be 5, so just below that. And then from 6 to 9 pounds, it's only 2. Could shade those in. Don't have to, but. Finish the whole packet in. Did anybody go back and listen to the video yesterday if it sounded better with my new earpiece? And why do you? All right. Any questions there? All right. Mr. Math's classes test scores on a recent test are 71, 75, 80, 83, 91, 66, 62, 78, 75, 98. Oh, wow, that's a lot of them. Draw a histogram to represent the data. Are there any data points that appear to be outliers? Well, that's a lot of. Well, I guess you'd have to lose one by ranges. Yeah, let's do this one with ranges because there's too much variation there. Try to do. So let's do. What's the minimum here? 40 is the least. And then let's just go up by 10. So this will be 40, 50, 60, 70, 80, 90. And then we'll just add up how many fall within each range. So let's let the first one be anything between 40 and 49. How many are there between 40 and 49? Yeah, just let's do what I don't think there'll be more than 5 of anything. 50s. There's 6 70s. Fine. All right, so let's do 6. Then. That'll be the highest. And then 3. And then, so we got like 1 in here. We used it. Then how many are between 50 and 59? How many are there in the 50s? 1, 2, 3. Said he saw a fourth one? Oh yeah, 52. All right, good. Uh, 60 and 70, so that's in the 60s. We have 3. Am I counting that right? 3 60s. And then you said in the 70s there's 6 of them, right? In the 80s, we have 1, 2, 3, which was the same thing as the 60s, right? And then finally in the 90s, 1, 2, 3 also. So how many were there in total? 8, 9, 10, 11, 12, 13, 16, 20? 20 in total. So in the middle of 20 is the 10th and the 11th number. Because they like the next, that's the histogram, but then I don't want to know there's any outliers. Which the bar graph is not, histogram is not my favorite. I mean, if there is going to be one, it looks like the 40. You know, because it says which ones appear to be an outlier. The only one I can think of that looks like it could be an outlier is the 40. They want us to confirm it. So the median will be the 10th and 11th number. So if we had 1, 4, that's 5, and 3 is 8. The 10th and 11th numbers are going to be in the 70s. So there's 8 numbers that came before it. It'll be the second and third 70. The first 70 is 71. What's the second 70? Are they both 70? No, 73. 73 is the next one. So the median would be whatever the average of 73 and 75 is. So the median 74. Oh, we're looking for outliers. It doesn't matter. It doesn't matter that the median is 74. I need to know my quartiles because we're doing interquartile range. So if there's 20 in total, that's an even number. You leave everything in. So we need 10 and 10. So we need to know the median of the first 10 and the median of the last 10. So the median of the first 10 would be the 5th and 6th number. The 5th number would be the biggest 50, and then, yeah, well, the biggest 50 and then the smallest 60. So it would be the average of 59, you said, and what, 62? Is there anything less than 62 in the 60s? So what the 59, Q1 is going to be 59 plus 62 divided by 2. It should be 60.5. Q3, if we're, let's see, there's 3 and 3 is 6, and then there was 6. So yeah, they'd both be in the 80s. You got 80 and 83. All right, we'll just take your word for it. I don't feel like spending too much time on this. So 80 plus 83 divided by 2 is 81.5. So what's the interquartile range of 21? The IQR is 21. 21 times 1.5 is 31.5. 31.5. So we're looking to see if well, nothing is going to be 31.5 greater than 81.5. Is anything 31.5 less than 30? Actually, no, it's not. So there's no outliers here. There's no outliers. Do I have to write that down? Like, did I lose anybody? Did I go too fast? Once you find the interquartile range, which is this minus that, I subtracted the 2 that gave me 21. You multiply it times 1.5, which gives you 30.5. You would take it away from the smaller number, you would add it to the bigger number, but nothing falls outside of that. 60.5 minus 30.5 is 30. There's nothing less than 30. There's nothing greater than 112. So, any questions on that one? All right, there's 2 dot plots here, but I'm only going to do one of them. Unless it's fast. Maybe if it's fast, it'll be both. The students in one social studies class were asked about how many brothers and sisters they have. Here's a dot plot. How many students have 6 siblings? The students in the social studies class were asked about how many brothers and sisters they have. So, one class. Oh, so okay, 3 kids don't have any. 1 kid has. Three kids have 1 sibling. 3 kids. Okay, so this is so going up here is going up is the number of students, and then on the bottom is siblings. So how many students have 6 siblings? Yeah, correct, 1. That's the one at the end. How many of the students have no siblings? 3. How many of the students have 3 or more siblings? 3 or more can mean everything from 3 to 6. So that's 6, 11. Counting 11. If they ask you how many students are in the class, what would you say? I'm counting 20 also. Yeah. That was pretty fast. We can do the last one. The resting pulse rates were recorded for 16 boys in gym class before they exercised. Here's a line plot. What is the range of the pulse rates? Okay, so range is greatest minus smallest. It is 6. Yeah, the range is 6. 85 minus 79 is 6. How many boys had a pulse rate? These are all boys, right? Yeah, so had a pulse rate over 81. Okay, so look, I want to point this out. Notice how this said 3 or more. This one just says over. So on the one above, I included 3. When I came up with that 11, I included the 3. But here, I'm not going to include the 81. So how many are over 81? Yeah, there are 9. I think I'm going to give back the test or the quiz from last week on Friday. Because we still have until next week. Like, we have plenty of time. I'm going to give it back on Friday. But if you're confused on something, ask. Because I really feel like that quiz should have been pretty easy. Like, I think almost everybody should have got hundreds. And there were some hundreds, but overall, it wasn't as good as I thought it was going to be. So even if it seems simple, if you're stuck, say something. How many boys had a pulse rate of 83? Okay, exactly 83. These next two, I was looking at it. I'm going to go through these fast because we've already kind of talked about this. And some of the words here, I mean, I'm not exactly sure what they're getting at. I mean, see, like, there's this fill in the blank, right? The center, what are the main measures of center that we talked about? Huh? Median and mean, yeah, mean and median. Mode is I guess a kind of type of measure of center, but it's not a very good one. What are some measures of spread? You want to see how spread something? No. What are some measures of spread? Now, we want to see how spread out something is. Like we literally just did one. There's a measure of range would be one if you want to see how spread out something is, max versus min. Another one you could say is interquartile range. Is also a measure of spread. Shape. This is one. Like there's one thing I would fill in the blank here, but I don't know. I don't have a key, so I don't know if they're going. What is the shape of a distribution described by? Yeah, I would say the table. I would go with the table, but I don't know if they're going with some unusual features, gaps, and outliers. But anyways, so here like spread, right? They had this fill in the blank here, but from what I can tell, I didn't make this. I didn't make this. Okay, so from what I can tell here, they wanted to say that this has a smaller spread, or less spread, and this has a larger spread. It's more spread out than max in the middle. Spreads all the way from 0 to 10. This one only goes from 3 to 8. Okay, now we get into skews. What did we call this first type of skew? We've already talked about this. Yeah, symmetric. First one is symmetric. We don't really get into normal distributions, but if you ever do later on, a normal distribution is a type of symmetric distribution. All normal distributions are symmetric, but not all symmetric distributions are normal. You may not know what a normal curve is. If you ever hear it, just know that a normal curve is a type of symmetry. Okay, how about this next one here? Okay, you could say skewed negative. I would use skewed left more. I just think that word is more likely to show up. But yes, if you know negative, great, fine. How about this next one here? Skewed right. Sam, why is it skewed right? Why is that distribution skewed to the right? The tail, very good. This thing is just like a little tail, like a little mouse with the tail. The tail's on the right. On the first one, the tail is on the left. And the next one, what type of distribution is that? This is uniform. And these are those unusual features that I said on the last page. Which type of unusual, quote unquote, unusual feature is demonstrated on the first one here? Those are the two unusual features that they mentioned on the last page. Yeah, this one looks like it has a gap. It's missing values in 4 and 5. What is the next one seem to have? Yeah, it appears it has an outlier on the 9.